of the drug zopiclone for treating insomnia in older subjects. Before treatment with zopiclone, 16 subjects had a mean wake time of 102.8 minutes. Okay, 102.8 minutes. Jot down our information. After treatment with zopiclone, the 16 subjects had a mean wake time of 98.9 minutes. Did they give us a standard deviation? No. So after, X bar is 98.9. And our sample standard deviation is 42.3. And they tell us where the data comes from. Assume that the 16 sample values appear to be from a normally distributed population and construct a 98% confidence interval estimate. So we want 98% confidence interval. That means that alpha is 0.02. Degrees of freedom would be 15. T sub alpha over 2. Okay, we need to go to our table again. Alpha is 0.02 in 2 tails. Degrees of freedom is 15. Okay, 0.02, okay. I think I don't have to move the window or anything. 0.02 and 2 tails. Come down to 15, we get 2.602. So E times our 42.3 square root of 16. Okay, let's see if I can do it this time. 2 times 42.3 divided by the square root of 16, or you could just enter a 4. Okay, I got 27.52. I carry it one more place than our mean. Okay, so I want to take X bar 98.9 minus the 27.52 and 98.9 plus the 27.52. Minus 27.52. Okay, so these would be minutes. There's our 98% confidence interval. Okay. All right. Looks like, let's see what else. What does the result suggest about the mean wake time of 102.8 minutes before the treatment? Because the 102.8 would be in this interval, it doesn't guarantee that there's any kind of improvement. So it looks like that it's possible that the zopiclone does not have any effect, that it doesn't really help that much. Now, I also want to do this with the calculator, since we won't need our table anymore. So let me close that one if I can. Okay, and I want to bring up my calculator. Okay, I'm going to clear off my calculator while this is coming up. And what we want to focus on while that's coming up is, let's remember a couple of things. We want 98% confidence level, n is 16, and we need to give these two values. So those are the things we're going to need for the calculator. It's very slow this morning. Window over slightly. Okay, so I want to clear the calculator from what we were working on last time. And again, we're going to go to Stat, and we want to go across to Tests. So what I need, we don't want any of the tests. Those are the hypothesis tests. We want an interval. And because we're working with the t-distribution, because we do not know the population standard deviation, we want number 8. And now you have a choice between entering the data using one of the lists or stats. And in this case we have stats, so enter. Alright, so I need to come down, and our X bar was 98.9. Okay, our sample standard deviation was 42.3. Our number was 16. Confidence level 98. I think that was right, 98%. This we enter it as a decimal. And then we want to calculate and press enter. Alright, so again, the confidence interval is given in interval notation. So we're seeing it goes from 71.379 to 126.42, which you could round off if you wanted to 71.4 to 126.4. Let's see if that's close to what we got before. Okay, yes, it's exactly what we got before. So you can use the calculator here. And actually, we're going to use the calculator on number 20. It said, listed below are the ages and years of randomly selected race car drivers. Construct a 98% confidence interval estimate of the mean age of all race car drivers. So, alright, now we have a list of their ages. So what we want to do is we want to go to the calculator, and I'm going to clear this. I'm going to go this time to Stat Edit. And I'm going to enter the ages of these race car drivers. So I have 32, 32, 33, 33, 41, 29, 38, 32, 33, 23, okay, 27, 45, 52, 29, and last one's 25. Okay, so we've listed all of the data in L1. So now we're going to go to Stat and Tests. And again, we want to construct a t-interval because we do not know the population standard deviation. So I'm going to press Enter. This time I'm going to go highlight data. We're using the data. We don't have the stats. Our list is in L1. Each number counts as a frequency of 1. Confidence level, I do want 98%, so that's correct. So I want to come on down. These are all correct. And to calculate and press Enter. So I'm getting the mean age is between 28.4 and 38.8. Or if I wanted to write it in the traditional way, mean age of drivers. So you can see that you can use the calculator. And let's see, 28.4 to 38.8. So we're correct on that. All right, the last thing I want to do is to do one where we calculate the sample size needed, and we're going to do number 26. It says a study of